Okay, before moving on, let's just practice some. I mean, let's get a good grip on functions and multiple functions and handling those. And the best way to do that is to solve actually a problem. Remember, we solved a problem when we were done with if conditions. Then we solved another problem when we were done with loops, just to get a good grip on loops. Let's solve a problem. Let's just solve a problem using the functions, just to get a good idea of functions. What kind of problem should we solve here? Should we solve an older problem? Last time we solved a problem using loops that were sorting a list. Why don't we solve the same problem but in a different way? So let's go to Jupyter and see our file, Jupyter file. We have actually solved a function somewhere using loops. Just let me just find that out. Oh yeah, they're here. So given a list of numbers, let's this. Make another list, or maybe the same list, that contains all the items in the sorted order from minimum to maximum. Your result will be another list like this. And we solve that using loops. Okay, let's solve the same problem. Exactly the same problems. Let's solve the same problem using a different way, using functions, just to get a grip on functions. So let's say that's our problem we want to solve. So that's the problem again, and we want to solve that. So how can we solve that? To solve that, let's first define a function. Let's just make a function. Let's just make a function that let's say define find minimum, and the function accepts a list and returns the minimum value in the list. Not only the minimum value of the list, but also the position of that minimum value. So find minimum as well as minimum as well as the position of the minimum in the list. So how can we solve that problem? That's one standalone function. No matter what list you pass in, it will find the minimum. Okay, as long as the minimum is defined for the items of the list. For example, the list items are, let's say, all numerics. Okay, how can we do that? Let's say minimum value is the list 0. That's, let's say, the minimum value, and right now the index at the minimum value is, let's say, is 0. Okay, like we did in the loops. Like it is kind of the same code, but let's write a function for it. Okay, so that's a function, find min. So how can we proceed? What should we write here? Let's see a counter. Let's say counter is, let's say, or I maybe. Let's say the counter right now is 0 for x in L. If x is smaller than our minimum value, if that's true, then the minimum value indeed is x, and the index where we found that is I. Okay, great. Else do nothing. I mean, else just go away. And I plus equals 1. So move on. So I is just the position. So I is moving on and on and on as you follow the list. And m contains the minimum value, and idx variable contains the position of the minimum value. So that's the function. For readability, we might be adding an else clause just to write pass, and that means the if condition finishes. I mean, if this condition holds true, do that stuff, otherwise do nothing. That's just because of readability. If you want, even if you don't write the else clause in pass statement, even then everything is fine. So let's call this function just to test whether this function is working properly or not. So let's just find, oh, we haven't returned anything. We need the minimum value as well as the index. So return minimum value as well as the position. So return that. Okay. Oh, but we are returning that inside the loop. That becomes in the body of the loop. Oh, no. That's bad, because even in the first iteration the return will be called, and even in the first iteration the function will finish. Indentation, remember indentation? Now that's better. Now this is no longer inside the body of the loop. Great, that was a bug, we fixed it. Great. Okay, so let's call find, let's receive a, b. So a will contain the minimum value and b will contain the index of the minimum value. So find min, for example, and the list, let's give it the list 1 3 4 2 3 4 0 9, let's say. Now the minimum value is 0, and that minimum value appears at 0 1 2 3. That's the third index. So b should be 3, a should be 0. So let's see what's the value, what's the result. So print ab. So a is 0, yes, and the position of minimum is 3. I guess it is working fine. Great. So that's one function, find minimum. Let's find another. Let's write another function, swap. So define another function. Let's say swap values, and what we do is it actually accepts two indices, index 1. It actually accepts a list, then two indices, index 1 and index 2. And what it does is it actually swaps the value of index. So index 1 value should go to index 2 position, and index 2 value should go to index 1 position in the same list, and then it returns the list. Okay, great. So so that's a good example. It accepts a list type variable, it accepts index type variable, which are integers. Great. So let's define a variable temp that contains L idx index 1. Just store it in a temporary variable. Then at this particular index 1, just copy this value. Don't worry, we will see lists in detail later on. Now now at index 1 the value of index 2 is copied, but it is not overwritten because we already have saved the value somewhere before that copying appears. So L at idx2 is simply temp, and now return the list. So that's how you can swap the two values if you want. Great. So let's just check it whether the two values are swapped or not. So let's say list is 2 3 6 and 7. Let's say that's the list, and let's say we want L2, that is swap values, and let's say we pass the list and we want the values to be swapped at position 1 and position 3, which at position 1 the value is 3 because the position starts from 0, and at the third position the value is 7. So we want these to swap. So the result will be 2 7 6 and 3. Let's see what's the result. So let's print L2, and yeah, it works. Great. What else do we need? So we have find minimum function, we have swap values function. What else? So yeah, what should we do? Now let's write the main function, sorting. Let's write that function, and we will use these kind of functions inside that function. We will call these functions. So let's define sort list. Let's say that's our function. It accepts a list and it returns a sorted list. Okay, what should we do? What do you think? What should we do for the very first time? Well, first of all, we should check whether all these list it contains the list contains all the numeric values or not. Let's say we are just doing this for numeric values. So we should first check that all the arguments are of numeric type or not. For that, we should write a function that should do that. Oh, remember that function is all written in a module. Remember that module? We made that module ourselves. So we can import that module if we want. Import remember that my universal functions And we just need that function. We just need that function. One of just from my universal functions, import what? Import check if numerics, check if not numeric, as, so you can write that function name something else, but just this. So you import that function. Now you may be able to use that function. So after that, you can use that function. If check if not numeric list. Remember that function returns true if all the values are numeric, otherwise it returns false. So if it is true, then move on. If it is not true, what should you do if it is not true? If it is not true, then you might be printing an error, list does not contain numeric values, maybe that, and then you just return. That's it. I mean, return. Don't need to write anything in return. Fine, great. So else, we need not to write else because this return will take care of that, but it is for readability, it is good to write else. If all are numeric, then what should we do? Okay, what should we do if all are numeric? What we do is we will be doing what? We will be finding minimum. We'll be finding out the minimum, and then we will be swapping the minimum from what should we do? What we have already a function find minimum that we can call just right away. We have a function swap values that we can call right away. We already have used this function. How can we combine all these functions? How can we use all these functions just to achieve the problem sorting? We want to sort a list. How can we do that? Okay, yeah, that's it looks like yeah, it looks like a different thing. Maybe so let's just write out. Let's just for x in the list. Let's start thinking here for every element that is in list. For x in list, what should we do? We should find out the minimum and swap the minimum with x. So we should find out the minimum as well as the index of the minimum, and should swap it with the value x, and everything will become great. Yeah, I guess yes. Okay, so what we are going to do is we are going to maintain a counter. Right now the counter is 0, which is just the index. What we are going to do is we are going to find out the minimum and the index where the minimum lies. So by find minimum in the list, so it will return us the minimum as well as the index where the minimum lies. And then what we do is we will say okay, okay, what we want to do is L is actually L is swap values with index C, swap values in the list with index C. So index C should be swapped with IDX. Yeah, and C plus equals 1. Will that work? Will that work? So after this, will the whole list be sorted? So let's return list L. Is that true? I mean, we are finding out the minimum value one by one. The only catch is the list is updated here, and oh, there is a problem. when we are finding out the minimum, we are finding out the minimum from the list, and every time the same minimum will be returned. That's a big problem. So looks like this find minimum function is not doing our job. What we need to do really is we should go to find minimum function and give it that start your find minimum from a particular index. So don't search the whole list to find the minimum. Start finding out the minimum from the following index, for example. So let's give a start index and maybe an end index, but let's give a start index. So start searching the minimum from right from there. How can we change all the code right now? Oh, that's a bad thing. Let's change the code. Let's say that's the start index. Start index. That's this. The index right now is start index, and I is also start. We may use a range function here. That might be much more feasible to us. So let's use a range function rather than this. Let's change the coding a whole lot. That's a bad thing. We need to change the code. For I in range, starting from start index, starting from start index, ending at length of the list, and doing a step of 1. Okay, now x is really list at the index I. Okay, if x is smaller than m, then this is that, and index is I. Otherwise this, we need not to do this because this is happening automatically, and rest of the story is same. I guess yes, that will work out. Okay, great. Oh, there is a problem. Oh, we just missed this colon here. Great, we fix it. Okay, now swap value is there. Maybe this works, maybe it doesn't. Maybe there is a bug. Let's see. Let's just call this function. So let's call this function L2 is sort list, and let's pass the list as 2 1 5 3 -8 17. Let's see. Let's pass this list and see what it returns. If it returns fine, we might be happy. Otherwise, we will see where is the bug, if there is a bug. Oh, list does not contain numeric values. Why not? List does not contain numeric values? Why is that happening? List actually contains all the numeric values. Where is the problem? Check if not numeric. Let's see the implementation of check if not numeric. Let's see that. Check if not numeric. Let's see the implementation. And where is the bug? Because all these are numeric. So check if not numeric, x in args. If not is instance, then return false. So if everything is int or float, so if x is int or float, then otherwise return true. So it returns true if all are numerics. So it returns true if all are numerics. So not true means false, and it why it is returning false. So let us just see why it is returning false. That's a bad news. Something is happening wrong. Let us just see how this is working. So let us just check if not numeric, and let's pass the list, this list, and let's see what is returned. Let's just print the return thing. Print. It is either true or false. So it returns a false. Why it is returning a false? It is a bad thing. Why it is returning a false? Let's go to the file. Let's go to the file. Here. Sorry. Let's go to the file. Here in this directory. Let's open up this. Maybe we open this in simply a notepad. Maybe a notepad. Why not? Or maybe some other fancy editor. Let's open this up and see what is happening. Format, font. Let's have a bigger font and see what is happening. Let's have font of 20. Yeah, bugs are bad. They're really bad. For X in args, okay. If not is instance, so first of all, is instance this, it will return true always, okay. If not true, which means false, then we'll move on and the loop will be running. If anywhere where it is finding out basically. So this is working really fine. Let's write this function somewhere inside our notebook and see what is, let's say, rather than this, let's write this function like check numeric 2, check numeric 2, check if not numeric 2, and let's call that function and see what happens. Check numeric 2. It is returning false again. Why it is returning false? That's amazing. Where is the false? So 2 is integer, yes. 1 is integer, yes. So true, 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 true. All these are true. Oh, -8 might be a problem. -8 might be a problem. Let's see. Maybe, I don't know. Well, it is still false. I mean, I'm stuck here. Guys, I'm stuck here. I don't know what to do. I have to debug this function. I have to go inside that function and see what is happening. So what we really, args, oh my god, the big trouble. Yeah, I found the error. We are passing a list, and that list is just one argument. That is not a lot of arguments. We have to pass all these arguments in a different way. I mean, if you want to, you're getting the bug. The bug is we are passing one variable, not a lot of them. 2, 1, 5, 3, 8, 17. These are not all different variables. For example, if we just go inside and print x for just first x, it is all the list. It is not the variables one by one. Let's see. Yeah, I found the bug. Great. Yeah, see, it is not a lot of variables. It is not a lot of arguments. It is just one argument that is in the form of list variable. That's the trouble. What should we do? Should we go inside and add another function, check if not numeric for lists rather than variable number of arguments? What should we do? Let's write another function that check for the list. Let's write here check numeric 2. It contains a list, for example. Just accepts a list L, or maybe L or whatever, X, or just simply you can call the or L list, and it goes through all the list and does the same job as previous. So now this will work. So the function that was there in our module is no longer working, and it will not work. Yeah. So we are not going to use the function that is in the module. We are going to write another function that will help us here, and we have written that, and here we go. We just change that function with that, and we just register that again, and let's see what happens now. Oh, there is another error. Which error? Find min missing one. Oh, we did not find this. Find min is missing the starting index. So the starting index is C. Great. Right. That's a problem. That's a huge problem. List is sorted. Oh my god, list finally is sorted. Oh, huge, huge, huge. So you see, you can call the functions inside other functions. You can call the functions from modules. If they are no longer working or no longer beneficial for you, you can write new functions. You can call them. You can, yeah, all that stuff. I guess that lengthy video taught you a lot of lessons, how to code actually. And this actually happens when you're doing tasks that are really big. You have to define different functions. You need to define different functions for modular approach and focus on each function as a separate entity, and that makes much simplicity in managing the code and bug fixing and all that stuff. You see, I fixed the bug by just noticing that, by just focusing on this function. I have not thought anything else. Just focus on that function, go and see the implementation, fix that, everything else stays the same. Yeah, so too lengthy. I stop here. Okay, now you have done a lot of practice about functions, loops, and a lot of stuff. That was all the basic programming in Python. In the next video, from the next video, we will see the real power, much more real power of Python, where you need not write a lot of loops and a lot of code, and still you will be able to achieve a lot of stuff. And for that, we need to go through the data structures that are available in Python. So from the very next video, we will start seeing strings. That's the data structure. We will see list in detail. We will see set in detail. We will see dictionary in detail. We will see tuples in detail. And after going through all these data structures and getting a good grip for the data structures, then finally we will move to the packages that are available for data science, particularly NumPy, Pandas, Matplotlib. And we will see, maybe I include one or two videos for scikit-learn as well. So hope to see you for the whole new phase in Python, the data structures. So we'll hope to see you in the next video.